Okay, so theory of supply and demand looks something like this. Okay. If we look at two different relationships between quantity of items, X, and price, P, and we look at that relationship from the point of view of a producer, somebody who makes something, versus the point of view of the consumer, the person who's buying the items, then there are going to be two different schools of thought. At least this is what the theory of supply and demand says. All right. So a supply version, a supply curve, tends to look like this when we look at the relationship between price and quantity. Okay. The supplier is the producer, the person that's making the stuff. Okay. And if you're a producer, if you're making things, theoretically, if you can sell items for more, or the more you can sell something for, the more motivated you might be to produce it. Okay? So there is a direct correlation as a producer in the theory of supply and demand that says, hey, if I can sell if I'm making pencils, right, and I'm selling the pencils for like 5 cents each, I'm not super motivated, but if I can sell the pencils for $1 each, and let's say the pencils are costing me a penny, I go buy the pencils for a penny, I turn around and sell them for 5 cents. I'm not maybe as motivated to make sure I have a lot of pencils to sell, but if I am buying those pencils for a penny and then I'm selling them for $1 a piece, the more I'm going to make, therefore, or the higher price I charge, the more motivated I am to do a quantity. It's a weird kind of function relationship in straight mathematics. When you look at a graph like this is the independent variable, so it would always be X controls Y. Economics is not that way. When they talk about a graph, they really kind of talk about them like one affects the other, kind of back and forth. So X versus Y axis is just doesn't have the same meaning in an economics graph like it does in a mathematical or purely algebraic graph. But the idea here is, if you have bigger pricing, you're going to want to produce, and you'll be interested to produce bigger quantities. Okay. Consumer, which is the easier one to understand, because that's more of what we are. All right. Or the demand curve, kind of looks at the opposite way. If the prices are super high, I'm not going to be interested in buying very many of those items, or you may not have as many consumers interested. But as your prices get lower, then you're more likely to have consumers interested in purchasing your product. So lower prices, which is what we would hear, higher quantities of sales can happen when you lower your price. If the t-shirts are $15 each, but then you say, or 2 for $25, okay, and the person goes, oh, well, $15 each, but 2 for $25, you're going to lower that price, your price per shirt, so you're more likely to get people buying 2 of them, because they're saying, I'm going to get a deal. We're going to also talk about what that I saved money by spending money concept. So lower price more interested in buying a higher quantity. That's the consumer viewpoint. Higher price, more interested in producing more. That's the supplier or producer viewpoint. And this is supposed to be sort of the magic place where everybody is happy, referred to as equilibrium. Okay. The consumers are feeling good, the producers are feeling good, everybody's feeling good. The market is kind of balanced because the people who are making the stuff are selling it for a high enough so they're motivated to make it, but the prices are low enough so the consumer is interested in purchasing it. Okay. All theories, right? I mean, there's lots of evidence to support, like they can collect data and show, but this is a theory because this is basically talking about feelings and numbers, that how people think and feel about things controlling their behavior and trying to measure that behavior and quantify that behavior with mathematics. Which is, like I said, regret. I regret not taking economics in college. I should have taken it. Especially if I'd had a good teacher, I probably would have really liked it, because I think this is really interesting. I think it's interesting to measure things. I mean, I always think numbers and things like formulas are interesting, but being able to connect that to emotions and things is it's fascinating. So, okay. So that's supply and demand, as I understand it. Now, we're at equilibrium. If we set a price, okay, and we draw a line for setting the price, and let's say we set the price right at equilibrium, okay, then all of the space that's up here, and there are so many different ways to look at this graph and different areas that mean different things. We're just going to talk about that one little area. That area is considered surplus, specifically the surplus relating to the consumer. Consumer surplus is that little area right there. Okay, now, here's what consumer surplus is about. Let's say you go to the store, you're in your mind, you're like, okay, I want to get jeans. I know what jeans I want, and they're $50. And you're like, okay, I'm willing to spend $50 because I want these jeans and I really like them and they fit me well and blah, 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 whatever other thoughts you have. So you're in your mind, you're like, I'm going to go online and I'll buy these jeans and they're $50. And you're totally okay with that. And you go to check out and it says, surprise, we're having a flash sale and you can have these jeans for $30. Okay. And you think, I just made money. Okay. You did not actually make any money, right? You're going to spend $30, but you were going to spend $50. So inside, you feel like you just made $20 because you didn't spend $20 that you were willing to spend. That's what consumer surplus measures. It measures, I have a hard time verbalizing this, but I think my example tries to explain it. Consumer surplus is when we quantify the amount consumers would have been willing to spend. Okay. you kind of calculate where everybody, how much leftover value, how much extra value the consumer is getting in the consumer's mind. Okay? If the price is at a certain point, if the market sets the price or the producer sets the price at a certain point, and all the consumers would have been willing to be up here and they only have to spend down here, they got some extra stuff, okay? And that's measured as consumer surplus. Okay? It's the space between where the price actually happened and where they would have been okay with the price. Okay? We usually calculate this entire space. There's other ways to break it up as well. This is actually it has lots of layers to it, but for us, for our purposes in terms of something we can do with an area, this area calculation as consumer surplus is something we can do. This side, if we wanted to talk about it, this is called producer surplus. Producer surplus is they're going to sell you the jeans for $30, but in 2 weeks they're going to sell them to, they would be willing to sell them to you at $20, and they would be okay with that. That's the money that, like, they still had some wiggle room where they were okay lowering their price and still being okay with the pricing, but you jumped in. You grabbed the price that you felt good about. I'm going to look for a video to talk about this a little bit more. I'm not doing a very good job explaining it in terms of the economics of it. In terms of the calculus of it, it's a pretty simple, straightforward way, and I'll show you in a minute. It has to do with identifying where the equilibrium is first. As soon as we get an equilibrium point, we can define this horizontal line and then calculate this area. And if we want to, calculate producer surplus as well. We're sort of focusing on consumer surplus though. Okay.
So, oops. Producer surplus would be like a clearance sale or something?
Producer surplus, yeah, I guess if you...
The stock's not necessarily there or it's limited, but it's also just not desired. So it's sold under money.
Yeah, it's... Both of these items are more about value, perceived value.
Yeah.
Okay, so when a producer sells something at full price, let's say when they would have been okay selling it, like they're saying, okay, so we have to sell this for at least $7 to make money. Okay, so then they put it out there at 15, and people buy it at 15. They go that difference in that's their surplus, where they would have been comfortable at 7, but you went ahead and bought it at 15. Okay. It's not any actual tangible thing. Like they don't actually get something, and you didn't actually get something. It's more of a perception of value.
So, I guess in my head I'm thinking about it like producer surplus would be like if they had some stock left over, they're just not selling it, so they don't really care about the value. And then maybe above equilibrium would be if you're at a dealership and they have to sell it at a certain price, but they're flexible in the margin.
That might be, yeah. That's probably a good way to.
Yeah, because I know if you do dealerships for expensive things,
right.
typically there's an MSRP.
Right.
Then there's a street price under that, which is still above whatever they bought it.
Right.
Yeah.
And that's part of the emotions of making purchases, especially large purchases, is the feeling like people are okay sometimes spending money if they feel like they got a good deal. So that's that thing. You feel like I made money. The car was this much and I got it for this much. So you emotionally are thinking, yeah, I got surplus. That's consumer surplus. Whereas a lot of times what happens is they do that and then they come back here and they go, okay, but do you want to add this on? Do you want to add this on? Do you want to? And they'll make up the money somewhere else.
Yeah.
So, but you don't think about it that way because you're over here looking like I started at $25,000 and now I'm getting this car for $19,000. I made money. Okay. But then they come over here and they're like, okay, well, extended warranty and blah, blah, blah. I'm just,
Yeah.
okay. It's so weird. Economics is so weird because it is so emotional. It's like emotional and numeric at the same time. Okay, so what does this actually look like as a straight up problem? Well, let's go ahead and take a look. We're going to do a linear one that's pretty easy first, and then we'll do a quadratic one that you got to use your calculator a little bit more to help you. All right, so let's say in this first example, so we'll do a pretty straightforward. We'll do a demand function where P equals 300 minus X. And we'll do a supply function where P equals 100 plus X. So P is kind of like your Y. X represents your quantity. Sometimes you'll see these with Q's. And so my quantity graphed relative to my price, and supply curves have positive slopes. Demand curves have negative slopes. And that's the first thing we need is the equilibrium point. Now, if you graph this in Desmos, I should already have this done. Okay, so let's see. 300 minus X and 100, oops, not 110, 100 plus X. Oops, how about X? How about X? Okay. Zoom out. Okay, so we can see we get a really nice scale, and we can see the intersection point right here at 100, 200. Love that about Desmos. Gives us those really easily. Very easy to read this off the scale as well, but clicking on it will give it to us. Alternately, if we needed some algebra here, we could say 300 minus X equals 100 plus X and solve that for X. So 300 equals 100 plus 2X. 200 equals 2X. So 100 equals X. Okay. We need the X and the Y value from the equilibrium point. Equilibrium. Okay. Boop. So whether you graph them and let Desmos or let the graphing calculator tell you the intersection, or you approach it algebraically, set them equal to each other. In this case, they're both linear, so it's pretty easy. Look at the scale, whatever you do. Identifying the equilibrium point, we can see it's actually going to be a really nice triangle. But I'm going to go ahead and just do my calculus and calculate that area. Let me grab that real quick. Toolbar. There it is. Okay. So just this guy. Make him smaller. Okay. So the integral you do for consumer surplus is always going to be the same. When we integrate, we are always going to be looking at the demand function on top, okay, because This is the region we're doing. So top minus bottom is going to be your demand function minus, and then this line we're going to consider y equals, in this case y equals 200. That's the y from the equilibrium. So demand minus the y from the equilibrium point is going to be the setup. And you're always going to integrate from 0 to, in this case, which will be 100, the x value from the equilibrium point. Okay. So honestly, you don't really have to see the picture for a consumer surplus. If you know which function's the demand, which one's the supply, you can find the intersection. You can build the integral without ever actually seeing what it looks like, because it's always in the same place. It's always controlled by the same functions. So in this problem, we would be integrating 0 to 100, and our demand function, 300 minus x minus 200 dx would be my calculation. All of these different areas represent different things. There's different pieces. You can put verticals and horizontal lines in different places and calculate different things. There's a lot of areas on this graph. When these are linear, some of that's just geometry, but when these get curvy, like the one we're going to do in a minute, we would do some calculus for sure to figure that out. Here, if I run the integral, okay, actually let's do this as P1. Let's make this P2. Oops. So functions, grab the integral, 0 to 100, and it's, in this case, my P1 function is my demand function. P1 minus 200 dx. Yeah. And so value here, consumer surplus available, $5,000. A lot of times where you see this is they talk about this sometimes in like public projects and what it'll cost you and cost the taxpayers, and you know, the taxpayers might be willing to pay more for something to happen, but since they can do it as a group, they pay less. But so there's additional, you get the item and then you get sort of the savings in your mind that you would have of not having to pay the extra amount. Okay, so y from the equilibrium makes the function that's the bottom of the consumer surplus region. The demand function makes the top of the consumer surplus region, top minus bottom, 0 to the x from the equilibrium point. Always the same calculation. All right, so let's try another one. Let's let you try this one. If I tell you that supply is modeled by 50 plus 0.2 x squared and demand is modeled by 100 minus 0.1 x squared, what will be the consumer surplus available in this model? So supply function and demand function, what will be our consumer surplus? A little bit like, this one looks a little bit like that. Go ahead and give that a try. See if you can find the point of intersection. I would definitely use my technology to do that, but you could also use some algebra. So we don't need technology to do this problem. It definitely makes some parts of it easier, but if we set these equal to each other, okay, we ultimately will get, I think we'll get 0.3, yep, if I add that to this side. So 0.3 x squared equals 50. So x squared equals 50 divided by 0.3. So yeah, I mean, a calculator definitely is helpful for this, because if we're going to take the square root of 50 divided by 0.3, that is not not something we can estimate super easily. Ooh, 0.3. So it's about 12.91. Okay. If we go to Desmos, let's clean all that nonsense off of there. Let that guy stay there. We'll say, we'll number the supply, 50 plus 0.2 x squared, and demand is 100 minus 0.1 x squared. Okay. There's the two graphs. The intersection, if I click, I can see 12.91, 83.333. So if I do y equals 83.33333, it'll do the horizontal line. Blow that up a little bit. So we are actually going right in there. And so here we go. We're going to integrate from 0, oops, that's a lot of zeros, from 0 to that intersection x, so 12.91, oops, right here, 12.91, and fix this. We use the demand function, minus y from that, and we have to make sure the algebra matches. Oops. What does it not like? What is it not happy about? Oh, I got some kind of nonsense right there. Oh, because I was trying to type stuff. Okay, there we go. All right, there we go. There, and there's that. There we go. So 143.47 is what we're talking about here in terms of that consumer surplus. 143.4 or 49, excuse me. I don't know why I went backwards instead of up. So 486. So how about 49? So that's 12.9, 83.3. 0, 12.9, and minus 8.3 dx. That's the demand function. Yeah, 143.49. Okay. 3.49. Okay. So essentially that will be the type of thing I'll have you do, one or two of those maybe on the quiz where you're calculating that, probably just one. Intersection point is the crucial item, how to use that intersection point or the point of equilibrium to then set up the integral to calculate the